Good afternoon, everyone, and welcome to the second keynote speech of e-Rum2020. My name is Emanuela Furfaro, and I will be the chair of this session. As you had the opportunity to see earlier with our first keynote speaker, you can ask questions through Slido. Ricardo, who is from the organizing committee, pinned a message with a link to access the website, to access Slido at the top of the events chat. So you can use it to ask questions or to upvote the questions that others ask. Okay, so it is now time to actually invite on stage our second keynote speaker, that is Jared Lander. Jared, please share your camera and audio. Okay, welcome on stage, Jared.
Thank you.
Jared is Chief Data Scientist at Lander Analytics. He's also adjunct professor at Columbia Business School, where he teaches the Introduction to Programming in R course. He's also extremely active in the R community. He's the organizer of the New York Open Statistical Programming Meetup. He's organizer of the R Conference in New York, Washington, D.C., and Dublin. And he's also the author of R for Everyone. Is that all correct, Jared?
Yes, it is.
Okay, great. So today he will give a talk titled Applying R at Work, and he will take us through a journey through the different ways in which different industries use R and the typical growth pattern at a company. So I now leave the floor to you, Jared, and I will turn off my camera and I'll see you again in about 30 minutes. I will ring an alarm after 27 minutes so that you can start wrapping it up, okay? Okay, cool. I'm really excited to listen to your talk, and the floor is yours.
Thank you. I'll share my screen. So, good morning, everyone, or good afternoon, as it may be. I understand many of you are in Europe. It's a shame we can't all be together, but at least we could see each other virtually. So, I've been using R for many, many years, and ever since grad school, at least, I've been using R for work. And I understand that can look different for different people depending on how their company wants to use R. So we're going to take a look at that journey. But first, we'll start 10 years ago. We'll go back in time. I feel a decade is
sorry to interrupt you, Jared. Can you just turn your camera off?
I just remembered to do that.
Okay, cool. I'm sorry about that.
Yep. So a decade is about a nice measure of time, so we'll go back about that far. And there was a title war raging. People were arguing, are you a statistician? Are you a data scientist? And people were trying to define the titles. They were saying, are they the same thing? Are they different? Come to today, and there's a similar fight. It's now data scientist versus machine learning engineer. Yet another change of titles for what, at least to me, is largely the same job. But there's a new entrant in this title war, AI specialist. Because when you rebrand statistics AI, things get a little more exciting. Stepping back 10 years ago again, there was the language war. We're all familiar with language wars. Back then it was R to SAS. That was the big battle. There were other entrants like Stata, MATLAB, SPSS, some other ones. But R versus SAS was the biggest. Coming back to the present again, there's a new language war. R versus Python. Everyone knows all about this war. But Julia's in there putting up a good fight, making an entrance. And SAS is sticking around, believe it or not. A lot of pharmaceuticals use it. There's some old contracts keeping it alive. MATLAB, for the most part, has gone away, except for people doing real engineering, like building bridges and jets. They still use MATLAB a lot. Let's go back in time again and talk about computing. A lot of what we do involves computing. We're at an R conference after all. Back then, our laptops could handle just about everything we wanted. In fact, this is the model laptop I had. We had blazing fast processors. They were breaking new territory. Moore's law was still intact. We were getting a lot of RAM, and we had 64-bit processors, so we could address all that RAM. And the data was big, but not so big that your nice laptop couldn't handle it. So you didn't need to go to the grid and do fancy grid computing anymore. Coming back to today, things have changed. Our data is much larger, and our laptops and desktops have not improved that much. They are much better than they were 10 years ago, but they haven't kept up with the pace of data. So we're turning to GPUs, as pictured here, and cloud computing. Thankfully, both of those have gotten a lot easier to use. So let's stick with now. Talk about what's going on nowadays. Who is using R? What industries are using R? This is a non-comprehensive list of industries where I have personally helped use R. You can see here it's a long list: banking, food, construction, manufacturing, genetics, publishing. It's a long list of industries. So how are they using R? How are they putting it to use? We are going to look at industry case studies, use cases, for just a few industries. And we'll start with pharmaceuticals. This is a big, important industry, and you want to make sure they get it right. This is life-saving stuff. So just a few of the ways they use R. Drug efficacy. You need to know how much compound is needed in a pill. You want to make sure you get that just right so you get the medicine delivered to the patients properly. We're constantly in a battle to discover new drugs. We're getting new ailments, as we're seeing right now. So we need to discover, is the term, new drugs to help people heal. It's very important to get prescription forecasting right. You need to know what demand you have so you make sure you produce enough of the life-saving medicine. And clinical trials, seeing how well the drugs work. Now that's really something. Because you might have heard, but SAS is mandated by the FDA, the Food and Drug Administration. We hear this all the time that you need to use SAS for clinical trials. We mostly hear that from SAS employees, or people who heard it from SAS employees, because that is a myth. The FDA lets you use other tools. Back in 2015, they put out the Statistical Software Clarifying Statement. Nice block of text here, and it comes down to the software needing to be reliable and testable. And R is both of those. So in clinical trials, reproducibility and traceability are essential. You must have consistency, and you need a paper trail. To achieve that, we can combine our markdown for writing the analysis in a reproducible fashion, our E&V for capturing the package states. This says what version of the package you're using. Git to track the changes both in the code, in the markdown code, the analysis code, but also the changes in your package versions. And Docker to bundle everything together so it's reproducible anywhere. You can put all of your analysis into a Docker container, give it to somebody, and let them run it the same exact way you ran it. So we're at an R conference, so I have to show some R code. And this is an example of using R in the clinical trial process. Now this is a package GS design for designing group sequential trials. Now this code doesn't analyze the data, but you're setting up the trial, see how it should be run. You set some variables like the number of desired events, the assumed hazard ratio, what power you want, and running the GSDesign function will tell you the number of events required to achieve a certain power and how to run it. So we pipe this into GSBound summary and show the cable, which is a way to show a table in Markdown. And we get this table showing us how you should design the clinical trial. Now again, this is just designing, not analyzing. You can analyze it in R, but I thought this code would be nice to show. And this is a two-stage trial where you do a number of trials and you see, is there a significant result? If so, you proceed to the next stage. And this tells you how many participants you need for each stage. Let's turn our attention to banks. We all want them to be doing good work to safeguard our money. Some of the ways they use R include targeting offers, what products they should advertise to different people, software efficiency. And this isn't just for banks, this is HR departments in general. Let's say your job requires you to use 5 different pieces of software in conjunction with each other, flipping back and forth, using them all. Maybe they should study this and say, hey, this person's using 5 pieces of software to do one task. Make it 1 piece of software, make their job easier. Valuations. It's really important to know how much something is worth. Whether that's an equity or a derivative, you need to know what you're spending your money on. And in the back of the house, there's fraud detection, a mandate for most banks. So fraud detection can take on many things, and it might not be just fraud. It could be a fat finger mistake that you want to catch before it gets processed. You want to see if people are using bad judgment and stop them from making silly mistakes. Or you could be going after criminals. So this anomaly detection, more than fraud detection, fraud is just one type of anomaly, can be done a few different ways. You can use supervised learning, either regression type models or tree-based models. Time series models, because a lot of financial data has a temporal component. And structural estimation to see, does this data today look different than it normally looks? And some common R packages for doing that, and you'll notice I'm not using hex stickers anymore because not all these packages have hex stickers, but GlimNet and XGBoost for supervised learning, and they're similar. And XGBoost not only does trees, it can also do a boosted penalized regression, getting it similar to GlimNet, which implements the elastic net. Fable and Profit are used for time series modeling. And Anomalize is a specialized time series package specifically meant for finding anomalies. Then you have RStan for doing any of this in a Bayesian manner. And what's cool is that Profit is actually written in Stan. So lots of different tools to do this. We'll look at just one example, Anomalize, where you take in a data set, you decompose it using STL, which is a standard time series method. You determine the outliers using the interquartile range method. You recompose everything and you make a plot, and the red dots are the outliers, the anomalies, the fraud or the bad judgment. And then you would put this down into a further analysis and say, how much does detecting each of those incidents of anomalies cost? And is that cost worth the price of investigation? And that's part of what goes into your calculation of anomalies, is balancing that cost. Turning to manufacturing, and this is manufacturing whether you are making metal or ink or medicine or jets. These principles can apply. Manufacturers will be interested in predictive maintenance. You want to know when a machine is going to fail so you can repair the equipment before it fails. Defects cost a lot of money, so you could use computer vision to look at items as they come off the assembly line and determine, are they anomalies? Are they defects? Should you fix them? For a lot of manufacturing, you have to worry about the temperature of the products as they come off the line. So if you could predict the temperature it's going to come off versus the desired temperature, then speed up or slow down the assembly line to accommodate that could be helpful. Electricity usage is one of the most expensive components of manufacturing. So if you could forecast in advance how much electricity you'll be using and buy it from a lower cost provider, that could be really helpful and make a lot of cost savings. And production optimization in general. This is really paying attention to your products, and you have warehouses and factories and customers in different places. You need to fulfill orders, so you need to know what to produce, where to produce it, and when to produce it. And that's a huge field of study. And even though it's a huge field, I will boil it down to convex optimization in general. These are problems like bin packing and job shop scheduling. And simulated annealing. This is when the price of your inputs can be impacted by your production. So when you optimize your production, you need to take into account the shifting changes, and simulated annealing is a great way to do that. There are many packages in R for optimization. These are three in particular that I've used a lot for manufacturing processes. OMPR for linear programming. Optimization does a lot, but I particularly used it for simulated annealing. And CVXR, which is this amazing package for general purpose convex optimization. It does linear programming, quadratic programming. If it's a convex optimization problem, CVXR can do it. It's really nice. So looking at an example of what might go into manufacturing, let's say you have a smelter and you need to melt different metals. You can only fit so much into a smelter at one time, but each metal that you're going to smelt has a different revenue stream. So you want to get as much revenue as you can, but you want to fill up the smelter as much as you can. You can only put so much in there. You can't pack everything in there. So I want to find out how many units of each metal can go into the smelter. I have my cap of how much it can hold. I have the amounts each one is worth, and I have how much space it can hold, for how much space each one takes up. Now this is essentially the knapsack problem. CVXR makes it really easy. You declare the variable that you're going to use to optimize. You put in constraints like the volume of all your amounts can only be up to a certain amount. You can't have negative amounts. You then specify your objective, the problem you're trying to solve. In our case, we want to maximize the revenue subject to these constraints. And you solve it, and it tells you how much of each metal to put into the smelter to maximize your revenue. Now, of course, this is a simplified example. There's many more considerations you need to think about, but this is a starting point. The insurance industry is really interesting because they went quant over 100 years ago, and actuaries tend to be really great statisticians. And they do a lot. I can make a whole slideshow about actuarial sciences, but that actuarial sciences is a big part of what they do, making these contingency tables. And actuaries nowadays, they get tested on R. It's on the actuarial exam. I know this because my book is required reading for them. And remember, they went quant all those years ago, so they want to automate all this reporting. This is a big part of their job, these reports. They built this whole system around these actuarial tables, or it was meant so that humans can go look up the tables and do their work. And we want to automate this process so they can catch up to more of the modern methods. And a sample workflow for this would be connecting to enterprise data warehouses because they have a long history of a lot of data, generating those contingency tables, and they had to build a whole workflow around this, write up their reports, and publish and distribute their work. A standard workflow that a lot of us have with specific needs for their industry. To accomplish this, they would turn to DBI for reading from the database, mortality tables or life contingencies for building the tables, our Markdown is Shiny for building the reports, Drake for composing all these steps together, and Drake could be used in any of these industries. And then RStudio Connect for publishing it and sharing. So looking at the example of Drake, you build a plan, and each of these steps are different steps you need to take on your data. And each one is a function. You apply a function to an object. We read in the data, we build the actuarial table, we generate a plot, then we use that plot and the table in the Markdown report, which can then be distributed. And you make your plan, and then you make it. Only parts that haven't been ran already or haven't been updated get ran. So if the first 4 steps have already been done, and it's just the 5th step that needs updating, Drake intelligently does just pieces of it and orchestrates everything together. Advertising. They have been using data for decades. Now they use R to do A/B testing to see is one version better than another. Targeted advertising. This is true for traditional advertising, but especially so in digital ads. Sometimes you want to use causal analysis to figure what caused something. Someone did this, and that caused them to do this other task. And funnel analysis. How customers progress through the sales process, how they go from one stage to the next. You would want to create a cohort of customers, say these customers all came in the same way, the same time, and follow them as they progress through the buying process. And see how many of them make it from one stage to the next. Because not everyone who comes to your site will go ahead and register. Not everyone who registers will purchase. And you want to see how they progress so you can figure out where to get the kinks out of the process. So you would use the dbplyr package because the data is typically huge, stored in a database. So you would use dbplyr to have a tibble point to a database table, and funnel join, written by Emily Robinson, to figure out how to join together these different tables based on both an ID and time. So look, taking straight from the vignette, we have 2 tables: when a customer landed on your site and when they register. That's the conversion. And we want to join these based on the user ID, but also making sure that you get the records of registration that occurred after the user landed. And so the after inner join function from the funnel join package does this for us. It joins the tables on IDs and makes sure that the right-hand table, you're only keeping records that occurred after the corresponding records in the left-hand table. Now, all of these industries have similar usage patterns. They have the same typical stages of R at work. And regardless of industry, most companies progress along the same path. First up, you have your maverick user. This is the first person to start using it. They tend to be enthusiastic about R. They're going to the meetups, they're reading R bloggers, they're really excited. They're most likely using R on a Windows desktop. They're not using Linux. They probably have a Windows laptop from work. And they're using R as an Excel replacement. And they're more productive than everyone else using Excel. And they're doing data munging and fitting models, and they're really doing cool stuff. After a quick bit, they form an R study group. This is a handful of employees who all use R together. They are enthusiastic users. They have a Slack channel for getting R help. They have another Slack channel for sharing R memes. And they're certainly collecting hex stickers. And they're really, really excited. And that's the important part. They're using R, they're sharing it with each other, they're getting everyone else excited, to the point that they bring in outside training. They get corporate training. This is when they've gotten buy-in from the higher-ups. The managers, the executives have said, R is looking great, we want to build this process. So they bring in an outside instructor to come teach a few days, a few weeks of classes and get their employees trained up really well. This speeds up the adoption by other analysts who want to get into R. And these early adopters, they get really excited and it accelerates their capabilities. So the next common thing is to get the R server. You're graduating from Windows to a Linux server. This is a centralized, controlled server for everyone to use. They're all using the same machine set up in the same way. They're using Git to version control all of their code. They're using projects. Often they start with RStudio Server Open, the free version. They're just getting their feet wet. And eventually many companies graduate to RStudio Server Pro and Connect. It gives them extra features that enterprises typically want. And they're using project package libraries. This is how you avoid dependency trouble. You have each project you do has its own set of packages, and you could track them in time using R, E, and V. So you have this R server. It's now time to productionalize your code. You're going to put this into production. Then you get told, but you can't put R in production. Only Java and Python are allowed. Nothing else works. It's impossible. Of course, this is a myth. It's just that some people in charge of production systems don't always want to learn something new, so you might have to do it yourself. So you're going to do this properly, and you're going to use a build tool like Make or Drake. Make is general purpose, Drake is specifically for R. If production systems can't interface directly with R, you expose the functionality as an API using the Plumber package. To make sure that your code for production can be repeated if something goes down, you want to be able to go back to the same environment, you're capturing your package versions with R, E, and V. This way you want to build it again, you go right back to the same versions, don't worry about dependencies. And you're going to package that all up together into Docker containers. This way you've recreated the system environment, the R environment, and you have all your analysis in there in this one self-contained unit. And then you can orchestrate that using a pipelining tool like MLflow or Kubeflow and make each step of your process a separate Docker container that flows together and works from end to end, all within R, all meeting production guidelines. That in itself could be multiple talks. And of course, you're going to use CI/CD to automate all these steps. You write code, you push it to your version control system, whether it's GitHub, Bitbucket, GitLab, whatever it may be, and continuous integration kicks off, building out, running the code, building packages, creating the Docker containers, and inserting into MLflow or Kubeflow. You've built everything end to end, and it all just works automatically now. It has never been easier to use R at work. We're in great times right now. 10 years ago, using R for work was harder and easier in some ways. There were institutional roadblocks. Sometimes they didn't want you using R. There could have been an ingrained culture of Excel or maybe SAS. And there was resistance to open source in general. And many of the tools we have now weren't invented yet. So you'd have to roll this yourself, which could be daunting. But the positive was that everything could be done on a single computer, which is really nice, made life easy. Nowadays, though, it is much easier to use R at work. Companies are very open to using R. And open source is everywhere. Everywhere you go, people want to use open source. Sometimes some lawyers try to tell you not to use open source, but the company wants you to, so you work it out. But open source is prevalent. And programming is the new Excel. This is becoming the new literacy. All the analysts are going to need to program. The downside is with the larger data, you need bigger compute. You need to use the cloud or a cluster. But fortunately, it's easier than before, and there's a great ecosystem of packages to help us do that. So you have to ask, what is your use case? What is your industry? What is your business? And you can go to cran task views to help figure out what packages to use to help accomplish your task. Then you say, what is your first project? What do you want to do first? You need to tackle something that's easy to show early gains, but it needs to add value. This way you get continued investment. Then you got to ask yourself, what is your end game? Where do you want to end up? What do you want to do? Do you want to have everything automated end to end? How do you want this working? What is your goal, and build your way there. You can't be tempted just to sprinkle AI dust on the problem. So many people think you just use AI and everything's solved magically. It doesn't work that way. You have to plan and build, put in the effort, map it out, and get it right. This takes work, but it's easier than ever before. And importantly, you should use R anywhere and everywhere. Any chance you get, I'm using R for everything. Thank you very much.
Okay, thank you. You actually finished a couple of minutes before. Okay, so we were collecting questions in the meantime, and thank you very much for your speech. I really liked how you went through the different types of people who work with R. I really liked that, and how you spoke about the change in how industries actually look at open source and R. I guess you actually experienced that in person, right? In first person.
Many companies. We help many companies progress along this pattern.
Okay, let me just share my screen where I can share all the questions that came through. Of course, more are coming through, so we may start from some and then. Okay, can you see my screen?
It is small. Let me see if I can make it bigger. I cannot. All right. So that first one is obviously a very loaded question.
Okay, obviously.
What I think is going to win the war, R versus Python.
Exactly.
In war, nobody wins. Now, it's interesting. So I am liking this, our current state right now, to, unfortunately, our VHS versus Betamax, where Beta was the better tool, but VHS was winning because it gained popularity for certain reasons. And unfortunately, I feel like R is the better tool, but Python is winning because it's more popular. You have a lot of Python people shouting, if you don't use Python, you're not a real programmer. That said, there are so many industries using R for real serious statistical work. If you have a place where they really want to do real statistics, I think R is still going to be around. I think it's going to end up being a stalemate for a long time until some new language comes along and obliterates everything, and we're writing interpreted C because it's fast and easy. I know interpreted C exists now, but I think it's going to be a stalemate for a while.
Oh, okay. Thank you. You're really passionate about that.
Oh yes, and I reined that one in.
Can I just ask you to stop sharing your screen?
Absolutely.
So that we just have one and everyone is focused on that one.
Yeah.
Okay, so I'll mark this one. Okay, then you can. So these are the most voted. We can go through those, or here you also see the latest questions coming. So I mean, we can pick any of these, but I guess we could.
All
keep
right.
going with the most voted, and then we'll then pick the last one when we have just 1 minute left.
Okay.
Yeah. So about teaching R, I mean, real world R projects. Which approach do you use? That's.
So case studies from some of the fields. So it's interesting. So I teach in the business school. And some of my students have asked, can you bring us business examples? And I spoke to some other actually business school professors, and they said, it's good to have just a general purpose learning of it. So I try to bring in interesting data sets, and there might be a business data set, but it might be something about, football, American football, or it might be something about pizza, something that gets people excited. The pizza data sets always get people really excited. So I don't necessarily go for case studies for a specific field so much as something that gets people excited. And for certain people, that is their field. Like we did a corporate workshop for a news outlet, and they wanted stuff that was relevant to their employees. So we managed to cook it up, and they got really focused. But I generally just try to do whatever gets people excited, regardless of the field.
Okay. I would like to go to the this second one here. Then we can go back to the one that is at the top right now.
Sure.
But I know you haven't tackled this in your presentation, but as you're doing a lot with a pretty big community, which is the our community in New York, I would like to, if you have any tips for people managing local communities, either as big as the New York community, but even smaller, if you have any tips.
Yeah. People ask me that a lot because most communities are starting out. They're like, we have more people attend a meetup than are in the community in general in a lot of places. And part of that's because we're in New York and it's a major city, people pass through. We've also been doing it for 10 years. And so I always say to people when you're starting out, there's a few things that are really important. First is make sure you have consistency. Meet every single month. Don't skip a month. This builds a cadence. People have something to look forward to, and you have consistency. Also, don't have the same person speak every month. It might be tempting to, if you're the organizer, you're the only person around who wants to give a talk, you just give the talk every month, but you need to have different people. You need to give that sense of community. And speaking of that community, I know from the beginning when I started attending, over 10 years ago and up till now, it's about the people. We had actually, someone told me, a few different people say this, that they don't even use R, they just come because they like the community, they like the people. And a big part of that for us has always been, we get there early and we have pizza. Yep, pizza's a big thing. Sometimes we have drinks beforehand and we have socializing. It's not networking, it's people developing relationships, forming friendships. We have an hour-long talk, and then we go to the bar. And whether you drink alcohol or you don't, you just come and you hang out and develop friendships. And I really think that's the crucial thing you can do, is the socializing and having people talk to each other and getting along and developing these relationships. So social before, social after, with good content in between.
Cool. That's a really good advice. Thanks. Okay, we can continue with the most quoted.
Sure.
You can pick any of these.
Well, you can see the screen a bit easier than I can, so if you want to pick up what you think is cool, okay. I can also lean in.
Okay, so how do you think we can promote the data science culture in our workplace? Do you have any tips about it?
It's all about excitability. Do something, a small one-off thing that's maybe outside your typical job description and show people it. But it can't just be something boring. It has to be something that gets them excited, that saves them money, that makes their job easier, and show them, hey, look at this cool thing I did, and look how easy it was. I did a project for a professional sports team here in the United States. And in the first meeting going into it, someone on the team said, hey, can we do this thing right before? We were in a coffee shop and said, can you do this analysis before we go into this meeting? Because that'll really get us good leads. And it's something they have been trying to do in Excel for months. And in about 15 minutes, we did it all in a few lines of our code. We walk in there, we show them, hey, look at this, these 3 lines of code, and look at this, what we just accomplished that you've been struggling for months. And that got them going. So a quick early win on something exciting.
Okay. And again, it seems like it's a bit like community, like getting people engaged and creating relationships, right?
Yep, it's all about people, no matter where you are, whether it's a business or the meetup, it's the people.
I think we have time for one more question.
Okay.
Okay, so we can go for the most. We still have like 15 questions. So I actually sorry we can't go through all of them.
If there's a way for me to answer questions afterward, I'm happy to go into like a room or something if that's what people want.
I don't think we have that planned.
Okay, sure. People can contact me.
But exactly, yeah, they can reach out to you anytime.
Yeah.
And you can, that's a little bit early for you, I think. But during lunch breaks, we have these thematic lounges. But it's like from 1 p.m. to
oh yeah,
1
I won't be,
yeah, that's a bit too early. But I mean, actually, anyone can reach out to you through Hopin with like with private chatting or private conversations. Or we can keep these questions and discuss them during our thematic launches, though you won't be there, but we can use them as a
guide. Listen, I'm on Twitter, Jared Lander, Twitter, and jaredlander.com. People can reach out. If you have like a last good question, it's hard to choose.
Yeah, it's hard to choose. So I'd go for the most voted one. Regarding R in production, do you have any thoughts on proprietary solutions like Microsoft Art Server, which can run R within an SQL server?
Yes. So I've been a long-term partner of Microsoft before that revolution, so I want to put the disclosure out there. And I will say that the R integration to SQL Server, and of course I just gave that disclaimer, I think it's one of the best things they've ever written. It is amazing. I had this one customer where they had a SQL query that was fitting a regression on a rolling window of 144 sliding points. It's taking 10 minutes to run, and it ran multiple times an hour. And I converted it to R code, which ran in SQL Server, and it ran in a fraction of a second. I think that's a great way to do it. I think it's amazing. Now, there are other tools from the tidy models, people like Max Kuhn and his whole team. They have a package, I think, called Tidy Predict, which will translate your R model for some models, mainly linear models and maybe some tree-based models, into SQL code. So you could do that on other databases. That said, the Microsoft SQL Server integration, it just works so nicely once you get the hang of it. So I am a big proponent. I do believe in open source. You need to have an open core and some commercial products around that to keep sustaining everything. So, and they just did such a great job building that SQL Server integration. I highly recommend it. But if you don't want to go the SQL Server route, there are open source similarities that aren't necessarily as seamless, but work nice too.
Cool, thanks. Okay, I think we can close the Q&A session here, but actually they're reminding me from the organizing committee that we also have some open launch, which is without moderation. So you just enter and you talk with whoever is there. And that's open right now, and it will be until the end of today's event. It will be open to tomorrow until the end of tomorrow's event and so on. So, so you can still join that and keep discussing. I'm sure you will find many people to discuss there. So now you sort of obliged to go there.
Is that under sessions?
You're going to be there.
Do I find it under sessions? Is that where it is?
Yeah, exactly. It's in the sessions.
Okay. I will go there and I'll stick around for 20 minutes or however long it takes to answer the questions and happily chat with people.
Yeah, sure. Okay. Thank you again. We were having a big applause at this time, but we had some technical problems. So unfortunately, we cannot send it, but I'm sure everyone loved your speech, and yeah, we've got so many questions and many feedback in the event chat, so feel free to answer those and continue the discussion. Okay, thank you.
Thank you. I'll be in the lounge. Thank you very much for having me.
Thank you. Bye.
Bye.
Okay, so I'll also stop sharing my screen. Okay. I now, okay, so today, the first day of e-Rum2020 has come to an end. I'm really happy that everything went smoothly, or as smoothly as as possible. And I will now call on stage Maria Chiara Fortuna, who is the chair of the organizing committee, and she opened today's event, so I'll be happy if she closed the event.
Hi, thanks Emanuela for introducing me. I'm also very happy to be here and to close this day. I'm very happy that everything went so smoothly and well. We made it, actually. I really want to thank all the speakers that were here today. They were actually, I think, 32. So we had already 32 speakers on stage and on session today. If you want to share the slides. Okay, I just want to show you some stats about the day that we had. And so, like, we already, I can try to remember, but like we already had, I think, when this, okay, 1,100 subscription for the 2-day event. And so it was something which is kind of incredible, meaning like we were planning a smaller event actually, and then for this coronavirus epidemic we had to change our plans, but this case just opened our event to a really wider audience. And I'm also really surprised and happy to see that really people from all over the world, as you can see from the map, were able to attend the conference, this day of conference. The other stats that you can try to see, I made some screenshots, so I'm not sure this like are the, oh no, it's still the previous one, thank you. Sorry, we had some cooperation for some technical issue that we are having. So we actually had, I think, a peak of 700 to 28 concomitant users. So simultaneously, people that were together using, like attending some portion of the conference. And I think a peak of 383 people on one parallel session. So usually parallel sessions are like kind of smaller, but like we were very happy to see that like so many people were attending, and already 32 speakers on stage. So I really want to thank all the speakers and all the chairs and the staff which is working behind this event, because I was really impressed for the work that everyone has done. And now let's give a look to tomorrow program. Tomorrow we will have we will start today with the parallel session 5 and 6. The first one will be about our world, and the second one about our introduction and still something about our world. We will have the third keynote of the conference, Francesco Bertolucci, that will talk about machine learning and the usage of machine learning. Then another parallel session. I think you are getting used to our work for parallel session. And so we will have, like, tomorrow will be slightly more focused on data visualization and Shiny. So we will have a first parallel session about data viz and Shiny, and then another about machine learning. We will have the thematic lunch during the lunch break will be about building community and diversity. And we will have in the morning 2 recruiting sessions, one from 9 to 10 by SDG, and another always by SDG from 11:30 to 12:30. During the entire day, we will have always active the sponsor exhibitors, the networking area, and the open lounge. The open lounge, like the one where Jared is right now. And then in the afternoon, okay, I can see the next slide. Okay, thanks. Thank you very much. We will have the second session of invited speakers, and the focus will be a little more, bit more on data visualization, on our introduction and machine learning. And then we will have something new, so the Shiny demo session. So you will have the time to familiarize with this other format, still in 2 parallel sessions and in the session area. We will have a short break that we called What If, where we will describe our ideas for the physical conference, so everything that we had to forget and throw away when we decided to turn the conference into a virtual event. And then we will close the day with the last keynote of the day, Sharon Mackley's, that we talk about data visualization from the perspective of a journalist. And so this will be like the program for the afternoon, but don't forget that we open and close every day with a yoga session. So now at 5:30, be sure to join the yoga session that's called Release the Tension of Your Back. So after an entire day on behind the desk, I think we all need to release our tensions, and so be sure to go there. And then tomorrow we will start the day with another session from 8:30, which is called Elongate Your Spine. So this will like close the day, this first day. I really hope to see you here tomorrow and for another full day, very full of content, and hope you enjoyed. And let me thank again all the organizing committee and the staff, which is working behind the scenes to make this event happen, and all our sponsor for providing all the support for making this conference free and open to everybody. Thank you very much, and see you tomorrow.
Thank you. See you tomorrow.
Bye.
Bye. Not sure